Hi, my name is Vladimir. It's midnight at Moscow time zone, and you are watching the Nightly Code channel. As far as you remember, we are working on improving the Focusrite device drivers for Linux. And in previous stream, we ended up with mute implementation, with software mute implementation for non-analog audio outputs. And as far as you remember, we have made an controllable output mute for SPDIF output and didn't implement the output for the line for the loopback. After the stream, I woke up the next day and reviewed the code I've written on the stream and decided to do some small improvements. So I'll just make short review of the changes I've made with the code to make clean why it's so. So, first of all, I still was worried about this statement written in my notes. As you see, we have the line outputs 1 through 8 bit assignment as 0 to 7. We have SPDIF 1 to 2 bit assignment for output for bits from 8 to 9, and loopback corresponding from 10 to 11. But we have an 18I20 device which has additional bit gap from 20th to 23rd bit, which probably is an added to ports which are not implemented in the device. So this gap is the problem which doesn't allow us to make a tight allocation of bits for a bit mask. So I decided to solve this problem by explicitly defining the bit assignment for the output ports, or output range assignment. I just want to change the order of nodes, since 18I8 is a junior model to the 18I20, which is a senior model in the Focusrite Scarlett device series. So I thought which way is better, and I decided that the best way to allocate the right bits for the outputs is just to define the plain array, where I just remember the following data, have the following data. The type of the port, this is the input port. Oh, this is the analog port, or SPDIF port, or line output port, or PCM port, or something else. Direction. The actual direction of the port, this is the input port related to the device, or the output port. The hardware offset. This is the actual number of the physical device port inside the hardware, how the hardware sees this. Count is the number of ports, of the sequential ports, which follow one to another and have the sequential numbering. So we can define with the hardware offset and count the range of ports. For example, the ADATE from 1 to 8, or SPD from 1 to 2. And software offset, how this range of hardware ports is assigned to software configuration. So how this range of ports is mapped to the software configuration. And this plain data structure, represented as an array, is pretty simple to perform different types of queries and take the data from this array for future processing. So let's look for the Scarlett tools for software port mapping, how it is defined. Of course, at first it has an Scarlett 2 device infrastructure implemented as a field. So we have additional. I have added additional software port mapping field to the structure, and below I have defined arrays for the different devices which map the physical ports to the logical ports of the software. So we can look at the 18i6 Gen 3 device, 18i8 Gen 3 device, and look how this array looks like. So we see that there is software port mapping for the 18i8 device, and I've just defined the mapping for outputs. Since we know, since at this moment we only know how the outputs behave in the software mapping of the driver. So we have analog outputs from 0, starting with the numbering from 0. Then total overall number of outputs is 8, and they are mapped to the 0 bits of the bit mask of the mute mapping. Scarlett 2's port type is PDIF. There are 2 ports. They also have numbering from 0, and they are mapped to starting with the 8th bit of the bit mask. And the PCM outputs from 10 to 11 including are mapped to the 10th bit of the software port mapping. As you remember, these 2 PCM outputs are loopbacks, and they are used for performing the signal loopback between the DAW and the audio device. So let's look for the 18i20 device. Where's the mapping for? Oh, here's the mapping for the 18i20 device, and the main difference is that it has additional 8-det outputs, and as you see, they are mapped to the corresponding bits, starting with the 12th bit, and the loopback bits are starting with the 24th bit, and this conforms to our mapping which we have in our nodes. And after that, after defining this array, we just link this, we store the pointer to the beginning of this array in the device infrastructure, and we can access this data structure in our functions. First of all, I have defined the additional function which allows us to get software port mapping of some port type, of some direction and some port number according to the information stored in the Scarlett 2 device info data structure. So here we just do conversion from one port coordinates, which we also know inside our driver, into other port coordinates which the Focusrite control operates. And these plain port coordinates are translated using our previously defined the software port mapping data structure. And after that, we can access our function to apply the mute settings. For example, We can, if we have the software config and this function is USB set mux, so we change routing in this function. We can check that we have software config, and if we have software config, we can translate the port number into the software mapping of the output and apply the state of bit mask or mute switches to the signal. Okay, so this part applies a simple but effective patch, which allows us to disable or enable the routing between the pair of input and output. And if we set the mute, the routing is forcefully denied. And if we unmute, the routing should be restored to the original state. But as we remember, the routing is read directly from the mute settings. But the Focusrite control can be configured in such a way. We have configured routing and muted several channels. And after that, the routing will be incorrect read from the device, since there are no connection points inside of the MUX, but in the software configuration, the proper connections are saved but not read at this moment. And moreover, we have more simplified function. At this moment, we already have more simplified way of creating mute controls. So we have removed the creation of mute controls from this loop and implemented the additional loop which allows us to create port mappings, mute switches. And this code is pretty unique as for analog outputs and software outputs. And this unification looks very good and works pretty well. So here we perform the right mute control creation for the device. And of course, we have a function which works with the mutes, and I think I should look for mute switch and find mute CTL get and mute CTL path functions. Mute CTL get. Yes. As you see, mute CTL get doesn't differ much from the previous version. It has additional debug messages enabled. I'll remove these debug messages when working on the final version of driver, but these messages are useful at this moment. And of course, the mute CTL put has been a bit improved and simplified. So now we have a a mixture driver which allows us to set the mutes. Let's check this. I'll connect to the virtual machine. Run the ALSA mixture and connect the device to the device driver or to the virtual machine. And additionally, I need to look at the log messages from the kernel. So I will just And wrong password. No. Uh, I will just make the demask and see that there are additional mute controls for line outputs. Oh yes, well, not for loopbacks, and here and there. And additionally, I can do what I can do: demask -W and switch to the Scarlett device. And look that we have the PCM11 capture mute and PCM12 capture mute. And in our demask, I will change the panels, the tabs. And in the demask, if we unmute, we can see that the also mixture initiates the change of the value of the parameter, and we change the software config, and we also update the mux, and moreover we know that the state of the mute has changed, and we can unmute this and see the same picture here. So we have loopback mutes. We have software mutes of the SPDIF. Let's check that they are present. Analog output and SPDIF output playback mute, and SPDIF output 2 playback mute. Good. And as we see, one mute is enabled, and of the second playback, and the first mute is of the playback is disabled. So the first SPDIF output is unmuted and the second is muted. So we can now probably disconnect the device and see that the state didn't change. We can do this. Just disconnect the device. The also mixture has lost the device. And now we can connect the device. See that the device has been detected. The driver has been initialized. And we see the mute switch mapping, the mute switch number, index, and the assignment of the switch of the mute switch. Yes, and we can see that SPDIF has the 8th index, and the 8th index is set to 1. Is set to 0, but returned to also mixture as 1. So the mute is disabled and returns to also mixture that this is disabled, since also mixture interprets once as mute is disabled and zeros as mute is enabled. It reverts the logical state of Boolean values. And as we see in the also mixture, the state of SPDIF outputs was restored. So that's pretty good, but still we have problem with mutes related to the routing. We can see that SPDIF routing can be violated. Probably the SPDIF routing is at the beginning of the mixture. I just need to ensure. Volume control, capture mute, or probably I need to select all. Yes, yes, and here when I select all, I should find the routing. Yes, PCM. I think SPDIF is before PCM. Speaker switching. That's not what we want. or from line to pad line. There are huge amount of controls, but we need to find their desired mix G, mix H, mix I, mix J, mixture input, analog output playback mute, analog output playback mute, demute. Oh, here. SPDIF output is set to off and SPDIF output is set to off. And that's not correct. So, in this stream, we will learn how the software configuration reflects the state of the output routing and probably implement something related to the routing restoring from the software configuration. So we just need to connect the device from disconnect the device from the Linux virtual machine and connect the device to the Windows machine. Yes. We have a Focusrite control. And in the routing, we see that the Focusrite control has restored the state of the device to playback 1 and playback 2. So, we need to, first of all, we need to check which alternatives we have. We have playback DAW, we have hardware input, and we have max mixes reached. Does the device allow only 4 mixes? I think we need to check, or we have set too many custom mixes. Okay. I think we should do the following thing. I think we can switch to the playback DAW only. We can route only one input to all outputs. And I think probably, okay, we will do in the such manner. Okay, we will route the playback 1 to all outputs. And as you see, we have updated the state of mutes and they were pretty correct. So we will unmute all. If you have any questions, you can ask in the chat. I see the chat and I can answer your questions. So we have unmuted all. We have unmuted all channels. And now we are ready to disconnect the device, launch the packet grabber or pickup capture, and make the first scenario. We will change the routing for a single channel. And remember the order in which we will perform the routing changes. So we will change the routing for the first channel. And then we will change the routing for the second channel. Since these channels can be combined into the stereo pair, I think this is a good decision to perform the routing for the first channel and perform the routing for the second channel. Then we can combine them into stereo channel and check the routing again. So let's run the USB pickup. CMD exa. So we need to enter 1, and uh, Scarlett 18 at 8 out 1 2 routing pickup. Yes, okay. I have launched our packet grabber, and now we can connect the device. The device has been connected, and now we can wait a bit and start the routing changes. So we will switch from playback 1 to playback 2, from playback 2 to playback 3, and so on. And back to playback 1. And then we will switch between hardware inputs. There are many hardware inputs, and we need to switch all of them. I need to pause. Okay. The sound is key. Hardware input SPDIF. Hardware input SPDIF. Hardware input ADET. Hardware input ADET. Hardware input ADET. And now we have a custom mix. We can set the custom mix and go back to playback 1. Good. We ended with the first output, and now let's repeat the same scenario for the second output. And back to the first. And now hardware inputs. And switch to custom mix. And back to playback 1. So it's enough. We can now stop the capturing. And I need to probably ban the spam bot. and go back. So we have a first scenario. We can see it here. And I think we need to analyze this scenario first. So we take this file and copy. So C program files, USB pcap, where's, oh, probably it's x86 or not. USB pcap, here it is, and we just take this pcap file and copy here and copy to the shared folder to here. Okay. Let's look then what's happening. I go to my folder. We have this file here. And now we can perform the decoding of this file. So I will just copy the name and do the run sh. Run sh ff this file name. Okay, all is good. And now we can open this file in Kate and analyze this file. Open, and here's our work directory. Oh, that's the wrong file. Here's our work directory. This. Oh, I'm again. I'm wrong again. Sorry. This, and we probably need the clean log. Yes, we need the clean. So we need to disable the line wrapping and go to the first changes. This is still initialization of the device. And here are the first changes. We see that bit F8, that byte F8 of the software configuration area has changed from 13 in hexadecimal numbers to 14. So we need to just take this and record somewhere in the new document. So this should be here and this here. Then there is set mux, nothing new, and nothing else. So we have just changed the number of the byte, the number stored in the corresponding byte, and updated the mux. That's pretty good. And this is the first action. What we did, we changed the playback 1 to playback 2. And we need to write here playback from 1 to 8 and to 1 back. So the second change from 14 to 15. Okay. I think this is the only byte that should be changed, so we can write this 14 to 15. Playback from 2 to 3. And I think this should be continued until we return back to number 13. So let's look. This is from 14 to 15, from 15 to 16, from 16 to 17, from 17 to 18, from 18 to 19, from 19 to 1A, and from 1A to 13. So we have values in the range from 13 to 1A. These values respond to the playback from 1 to 8. Good. Then we have changed the state of, let's recall, we have selected the hardware input. So we need to check how does the hardware input work. So let's look. We have the last change, and now we assign the hardware inputs. So there was a pause here from 13 to 1. Okay, this is the port analog 1. Let's look further. There's nothing else except the setmux. Then we have from 1 to 2, this is the analog 2, analog 3, analog 4, analog 5, analog 6, and analog 7. Do we have 8 analog inputs? I believe Scarlett has 4 analog inputs. I need to check again. Stop. And where are additional 4 analog inputs? I think I need to look at the backside, or I need to look at the screenshot of the Focusrite device. I think I need to do this. I need to have small pause. Probably no. Okay. So what I need to do, I need to look at the Google and look for the Focusrite 18i8. And look images. So here's the front panel, and where's the back panel? And here's the back panel. 1, 2, line outputs. This is 2i4, not 8. Oh, here it is. Okay, here are line inputs 5, 6, 7, and 8. So there are 8 analog out inputs, and that's true. So we have 8 analog inputs, and we assign them in the range from 1 to 8. From 1 to 8. This is the last analog input assigned to the F8 byte. So we can write down now that values from 01 to 08, 1, 2, 3, 4, 5, 6, 7, 8 are analog inputs from 1 to 8. Then the next scenario, let's look what's happening then. So we need to Open the log, and we have the 8, and how will the byte change then? We have a pause. Okay, from 8 to 9. So from 8 to 9 is the SPDIF routing. So the 9, I believe, to A is the SPDIF 1, 2. Let's check. This is SPDIF 1. And this is SPDIF 2. Yeah, I was right. Now, there is nothing said that says set mux. Let's look further. Now, from A to B is already related to hardware input, the ADAT. So the next set of inputs will be ADAT inputs, and there will be 8 inputs. So from A to A, B, C, D, E, F, 1, 2. From A to 12 in hexadecimal, there will be ADAT inputs. So let's check this. I guess this should do like this from B. Oh, I'm lost a bit. From B, OB, then to B, C, D, E, F, G, A, 1, 2 to 12. There will be ADAT inputs. 1, 8. Let's look and ensure that we are correct. From A to B, from B to C, from C to D, from D to E, from E to F, yes, from F to 10, from 10 to 11, from 11 to 12, and in the next part, I believe we have set the custom mix. Oh no, we have set to no, there are a couple of changes. We have the set mux, and we have additional changes in 1950 from BF to 0, and 90FA, I believe 19F and 90FA from FF to FE. And this is the custom mix. I think I need to check the mapping again and look at the offset. Then the offset 1950, there's nothing about it. Oh, here it is, 1950. There's mute setting for each mixer channel. So the driver changes the settings for the mixer channels to zeros. So it unmutes all mixer channels. And 19FA, what is it? This custom mixer routing bit mask. So 1 bit per output, 1 mixer disabled and 0 is the mixer is enabled. I think we will go back to mixer a bit later. And as we see, the routing between the hardware channels and the mixture are handled in the different ways. So when we work with routing, we need to check this mask first and check that the mixture is enabled for this output. And after that, we need to ensure that this bit is set to 0, and then we can interpret the connection as the connection of the hardware input or playback to the output port. Otherwise, we need to handle this connection as a mixture connection, as the connection of the output of some mixture to the physical output. So let's look back. Let's look again at this log and check that the changes have been made from FF to FE. FE means that the least significant bit was changed from 1 to 0. So we have the custom mix 1 enabled and connected to the device. We can check this by looking at the set mux call. We will ensure that we have changed the routing, so the mixture 1 has been routed, or the mixture 0, if we number the mixture from 0, was routed to the analog output 1. So let's look. I have a temporary project and not this. There is. Oh, I can take this and just new file, or I can do this in the gate. So I just start new file. I do replace and replace the spaces with new lines, and then no replace all. And now we see what do we see? And oh, we have the with plus. We have replaced this with pluses, so I don't need this. Okay, we have the. We should look that the analog 1 output is routed to mix 1. So this is the right state. So as you see, we are correct in our model, but the one problem is that this port assignment is different to the Scarlett 18i20 device. So we need to go back to the number of the byte, and this is F8, and verify the port assignment. So the numbering of inputs for Scarlett 18i20 device and the numbering of inputs for Scarlett 18i8 device. And here we should write down what we have found. We have found that numbers from 1 to 8 are assigned to analog inputs 1 to 8. So one, 8 analog inputs from 1 to 8. Then we have SPDIF from 9 to A. 9 is 9, A is 10. Yes, and this is true for the 18i8 device. Then we have SPDIF from 1 to 2. Oh, we have already written this. We have added inputs from B to 12. So that matches the uh, the port assignment for the 18920 device. Right from B, this is 11 in decimals, to 12, this is 18, right, to 18, not 19, 18. And here 18 too. And then we have the playback assignment from 13 in hexadecimal to 1/8. So here we see also the gap of a dead. This is from 19 to 20, 23, 23, 19, 20, 21, 20, to the 22. And from starting from the 23 up to 43. Oh, 23 plus the 20 will be, I'm lazy, I will just use a calc for this. From 23 in hexadecimal, I need to add the 20, and this is 55 in 37 in hexadecimal, or 55 in decimal. Okay. And in our device 18i8, we don't have this gap too, and we have exactly the 19 to 29. How did I get the 23 to 555? That's not true. 23 not hexadecimal, so I'll just write to 43. Yes, I was a bit lost. Thank you for donation, Edit. Thank you for donation. I think I can take this the donation to purchase the one more of Scarlett device, for example, 4i4 or 8i6, which I am currently missing, and I will have the full range of the Scarlett Gen 2 device, Gen 3 devices, except the Solo, Scarlett Solo, in my collection, so I can test the driver for all Scarlett devices. So your donations are very welcome, since I will use them in the right direction to purchase the additional Scarlett devices. Also, I want to thank all people who have donated me to purchase the 18i8 device. As you see, I'm using it very I'm using it very tightly, and this is very good that I have a dedicated device that allows me to perform the stream and describe what happens when we work with the device. And this also helps me to not to break my current musical configuration of my 18i20 device, since I'm using it a lot for my music work, and I don't want to make the configuration broken at this time. So anyway, for any donation, great, thanks. So let's go back and watch at the indexes. So we have from 19 to which number of outputs we have. I need just to recall. We have this, and we have 8 playback from 1 to 8, and we just need to add 8. This will be 27, and this is a playback from 1 to 8. Good. This is the wall port assignment for the i8 device. And I think we can fix this already in the code. So we can take this and go to the code of the driver. Here it is, and go to the 18i8 Gen 3. And define these ports here. So this will be a comment. And we now can define the input port mapping. And I believe the input port mapping should be before the output port mapping. So here's the output port mapping. Sorry, the input port mapping. All right, input. Yes. And we have the first setting the analog inputs, port in. Starting from 0, the overall number of inputs are 8, and we can map them to the index 1, software index 1. And I think for generalization we can add the none port here. Here we also set in, and we have only one such port, and this is mapped to 0. This means that there is no routing between this to this output. So the 0 value means no routing, and that's true that we define this at the 0 numbered value. So we have just set bit 0 for disabled routing, and bits from 1. No, I think that this should also be set as bits, but because there are bit mask, and there are numbering, and there are one related to the another, and we can call this bits since there are fields with bit masks. So from 8 to from 1 to 8 for analog outputs, that's true. 2 SPDIF inputs from starting with 9 for software configuration, and they have numbering from 9 to 10. That's and again we have 8 playbacks. These are PCMs, right? And they start, then they rust. We have a det. We also have a det, so we need to add a det. And there are 8 det ports starting with the index 11. So we will write from 11 to 18 for playback. For a det. A det 1 to 8. And after that, we have PCM outputs, and they are routed from, and there are the numbers are assigned from starting with 19. The overall number of ports are 8, and there are routed. There are assigned to the first port, the first physical port. So starting with 19 and ending with 27 is for not loopback, for playback. Yes, this source code is hosted on GitHub. You can go to my GitHub account, go to my fork of Linux kernel driver, Linux Scarlett Gen 3. Yes, this is the URL. And you can switch to the branch Scarlett Gen 3 mixer. Go to sound, USB, And here's the file which I'm working on. So here's a mixture Scarlett to C file. This is the last commit was 4 days ago, and there are changes applied by me, so you can see the actual changes that I've made to the driver here. So let's look something. Let's look the Scarlett to this. There should be data structures which I was referencing today. Yes, this data structure was committed here 4 days ago. So no problem. If you have more questions, please ask. I'll answer. We have made the port assignment, and I think we should do the same thing for the Scarlett 18i20 device, since we know that port assignment. I discovered this port assignment when working on the driver for 18i20. So we just need copy paste and update the numbering of the ports. I believe the changes will be not so different, just renumbering some values. Let's look. From 1 to 8, the NLEC inputs, inputs and inputs there. Then we have output. This is the mistake. I need to place the out in here, and in here, since these values are related to input ports. And I need to correct in here and here. Do some formatting, and now we can assign the values. Starting from 1 to 8 NLEC out inputs, then SPDIF, right? Then ADET, and then 19 to 22. This is the gap, and we don't reflect this gap here. So starting from 23 and having 20 ports, this is related to the playback. And I believe the playback should be split into 2 parts. I think this string should be corrected a bit later. Why? Because in the overall number of playback ports, there should be a loopback somewhere, I believe. So we will make this port assignment, and we will correct this if we discover something new about the port assignment. Now we have remember the port assignment, and now let's look what we have done with the second output. Let's go back and look the scenario for the second output. So we have ended with a bit mask, the mixture settings and so on, and then we have changed back to the 13 or analog input 1. Is that right? Let's look back again. Yes, to playback 1. So with this change, and also you see that we have disabled the mixture and disabled the mutes, I believe. No, we have just disabled the mixture. So the mixture is enabled by setting zeros and disabled by setting ones. Or maybe this is the mixture allocation. And 6 and A 6C 6E, this is the checksum or the configuration area. So we need just to look at this. So we have disabled the mixture assignment to the output. Is that right? I need to check again. The 19FA. Let's go back and look to the mapping. 19FA, custom mixer routing bit mask. 1 bit per out. 1 mixture is disabled, 0 mixture is enabled. That's good. And we have bit encodings. I think we will look at this a bit later. Also, we need just to check how the routing works without the mixture at this moment. So let's look at the second channel. The second channel scenario. Okay. Here was the pulse, and after that we have started to change the settings for the second channel. And I believe the settings will be exactly the same, except the number of the byte will change from F8 to F9. So we have changed the same values, but the destination byte is F9. F9, 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 and so on. So at this moment, we can say that we have discovered the input port naming or numbering. We have discovered the bytes which are assigned to the output 1 and output 2 analog outputs. And now we can go to the second scenario and run the second scenario where we do assignment to all outputs and grab the information about which byte is responsible for which output. So we will take our device again. I think I will switch from playback 1 to 8. This will allow us to fast find the destination byte, and we will just change from playback 8 to playback 1. This will be, or we can change in this such manner. We can change from 8 and assign some hardware input in increasing order. So we will just change to 8. The interface seems not being responsible very quickly, but that's not so significant. So we have assigned, I think probably it should, yes, it has assigned the routing at this moment. Now we can disconnect the device. And we can, I think I should close this. And at this moment, we need to capture the second scenario. Launch capturing and name the Scarlett 8 and I8 output routing. cap. And now we are ready to connect the device. Playback 1. Why playback 1? There should be playback 8. Interesting. Okay, we will just switch from playback 1 to analog 1, to analog 2. Oh, no. I think, okay, analog 2, then analog 3, then analog 4, analog 5, analog 6, analog 7, analog 8, then to SPDIF, then to SPDIF2, and loopbacks we will assign to 881 and 882. All right. Now it's all pretty good. We can stop the capturing and copy the settings, the second scenario from our local storage to the shared folder. And after that, we can run analysis. Outputs routing pickup. Yes. And there is a prompt to reload the file. Yes, we will reload the file since it has changed. And now we will look for the routing if we have applied. There's an initialization of the device. As you remember, we make some time gap between starting doing something in the UI, since we need to find the moment we have changed the device. So, and the first change, we have changed the F8 byte. So we will remember that the F8 byte is responsive for the analog output 1. I believe that will be the second will be the F9. We remember this. The F9, right there. Then we have reassigned this port, and this will be the F9 again. Yes, there will be F9 again. There will be FA probably. FA. So we will write down F9 FA. Then FB, FB, FC, FD. So FA, FB, FC, FD. And I think one more, it will be FF. FE. FE, not FF, FE. FE, right. So the FE is the last byte responsible. Oh no, not last. FE, there are 7 bytes, and the FF will be the last one responsible for the analog outputs. FE and then FF. Good. Then what after? What was the pause? Then 100. That's right. We just add 1 to FF and we get 100 in hexadecimal. So the byte 100 has changed, and this is for SPDIF. Then 101, I believe. Yes. And then 102 and 103. Yes. All right. As we see at this moment, the bytes have the same numbering to the output bits. If we look at the bit mapping, which we have written in our notes, the bytes from 0 to 7 are responsible for line outputs. The bytes from 8 to 9 are responsible for SPDIF state, and the bytes from 10 to 11 are responsible for the loopback state. So, what does this mean? This means that we can simply read the state of the port of the device starting from the F8 offset, and we exactly know the number of the port responsible for this value. So let's look into the code how the mix driver, the driver is initialized. Let's go back to the code and look here and go down, and there are functions, and there is Scarlett to read configs. And Scarlett to read configs works with the update input other, update monitor other, has mixture, update sync, USB get volume status, and there is Scarlett to USB get mix, and I believe there is a get mux call. Get mux. Yes. I don't know why the get mix is called before get mux, but okay. All right. And USB get mux just calls the device to return the state of the mux. There is specific call to the device, specific request, and probably there is nothing special. By the other side, we have the Scarlett 2 read software configs, which was implemented by me, and I think we have this here. And after that, after we have read the Scarlett 2 read software configs, we can initialize the software configs. I think there is a code related to the creating the mux controls, mux nums, and we need to watch at this function, and we will write the initialization code there. So we can look now at the code of this function. First of all, we are iterating here over their port type. So we iterate over the PCM port type, SPDIF port type, a dead port type, another port type, and so on. And then we determine the number of ports of output ports for each port type and go through this. And then after that, what we do next is that we generate the control to control this port, but do not read the state of this port from the software config. So, as you remember, we have the function to map the port to the index, and so we can simply update this function just by converting the port type, port direction, and port number. The channel is the port number to the software configuration number. And if the conversion succeeded, we can use it to read the software config. That's good. So let's start doing our job. We need to write the conversion. We need to write the code that will find the index of the number of the software config port. So I think this should be done here before adding the control. So I will add the comment to add the control to the mixture. And this code is fully responsible for adding the control to the mixture. By the other side, we need to check that we have the software config. So we need to add the comment check that software config is present, and then if the software config is present, we can try to translate the port number to the port index and read the value from the software config. So if private as software config is not null, that means that we have read the software config from the device. And here we can check int index and translate the port number to the index. So I just need to recall how the function is called. I need to add the additional panel. Yes, and SW port mapping. Yes, I think this function. Yes, and now we just need to go back to init mux. How it was called? Get mux, I think. I don't like this. I just need to add mux enums. This is the true name of function. And here we need just to call the Scarlett to get software port mapping and pass the direction. This is port out. Then pass the port type. This is the port type. And pass the port number, the channel. Then we need to pass the device info, and this is the info. Good. And after that, if we have the index set to correct value, this is non-negative value. Then we can read the value and translate it to the right mixture mapping. So, right, routing mapping. So, mm, uh, what I need at this moment, I need to look at the software configuration area structure. Scarlett 2 software config. Yes. And it already has the F8 offset output routing out mux. Here it is. And oh, sorry. And now I can read the value U8 software port number private software config out mux index. And here we just need an additional code that will translate the port number to a hardware port number. I think I need to go back to the getMux and check how the getMux is handled. So I need to go to the Scarlett 2 read configs. Oh, there is a typo. Yes. I will get back to this function. Yes. Yes, I can make typos. This is the usual process. Scarlett 2 add line in controls. Data read software configs. Oh no, add mux enums. Yes. Port yes, number, yes, right. This is just mistype letter. Nothing special. I would like to go back there a bit later and correct this. Okay, so there is Scarlett 2 read configs, and there is a call to Scarlett 2 USB getMux. And we can see here that Scarlett 2 USB populate mux is called, and we need to look how the value stored inside the mux is converted to the state of the port. So Scarlett 2 populate mux. And we have the Scarlett 2 mux ID to num and mux ID to num for the port out and port in. Okay. The only problem is that I don't remember the other Scarlett 2 mux ID to num. How does it work? So I probably need to look at how the numbering is performed in this function. So Scarlett 2 mux ID to num. So port type less than port type count. We iterate around the port type. Then base Scarlett 2 ports port type ID. Yes, the base in the mux. Count port count. Yes. If ID is greater or equal to the base and ID is less than base plus count. So I need to watch at the port definition for some device. For example, 18i8 Gen 3. And here are the mux assignments, I believe. Port count. Yes. And yes, that's right. Here's the mux assignments for different type of muxes. So this is the mux for 48 kilohertz discretization frequency. This is for 96 and this is for 892. Here what do? We look at the port type ID, Scarlett to ports. Yes, this is the structure, but at the top, here it is. We look at the ID. It has different ranges in the MUX. So we look that the ID is within the specified range. We have the number of ports. So I think the ports are numbered in the order the port type, in the order of port types. So you have the following port type order. I think I need to add the additional tab. So the ports will start numbering from none, then NALEC, then SPDIF, then ADAT, then mix, then PCM, then that, and that's all. So in our configuration, we have such mapping. We have such mapping. And we describe the ranges too. So we need to start the numbering of the port, and so we need to write the new function. So we need to write the function use b get mix. There was the function that converts the software number to hardware number, and do the reverse function that converts the port number to such coordinate system, probably, and then we can convert this coordinate system. Oh, I think we need to write two functions. The first function will convert our port to the desired coordinate system, and the second function will convert this port to the actual port number stored in the MUX mapping. So, I need to bend the butt. Okay, I've learned how to bend them quickly. That's good. So, there is a function. So I need to keep this, and on the left I will write the function. So format get software port mapping, and now static I think this should return int Scarlett to get. Oh, we can do the function that will do two things at the same time. The first thing, it will return the MUX index, and it additionally will return the direction, port type, and port number. I think that's good. So Scarlett2 get hardware port mapping. So we need to pass the pointer to int direction, to int port type, and int port number. Additionally, we need to pass the function, the information about the device, and pass the actual value stored in the device. Oh, I think the direction should not be used since we know the direction. So this is not the reference. So we always know the direction, but we don't know the port type and the port number. That's true. So, and also we need to pass I think the direction should be passed after all other values. And we know the direction and we know int software port number. And after that, we just start writing function. We will just copy paste this code, which checks that the software port mapping is present. If there is no port mapping, we just return. And now we can do this in the loop. So we need to int hardware, I think int mux port number assigned to 0. And after that, we can loop through the overall range of ports. And check that the direction matches. If direction doesn't match the port mapping direction, then we just need to continue the loop. We skip the records that don't match the desired direction. If now we need to check the port number. We need to check that I think how should I do this? We have the software port number and we have offsets. So we just need to check that this software port number is within the specified range. So we need to find the proper record in the software port mapping. We need to find the corresponding record. So we need to look up this software port mapping. Oh, we are looking through this port mapping. Oh, so that's not good. We need to look this port mapping inside the loop, and we need to set the additional loop variable. So we need an external loop. In the external loop, we will look for we will go through direction. Probably, I think. Or we can simplify and really write two functions. I think we can write two functions. This will be much more simpler. So we will write two functions. Get hardware port mapping. If there is nothing, then we'll just return -1. That means that we don't have hardware port mapping for this software part. So now we just need to check that. I need to disable line wrapping here, and we need to check that the port number is just in the range we have specified in our settings. So we need just to check that SW port number is greater than the port mapping software offset, and additionally check that software port number. Oh, I need to ban them one more bot. and check that software port mapping is less than the same offset plus the count port mapping count. Yes. And after that, if our port number matches the range, we can just do the simple thing. We can just return the right value. We can write a port type, a port mapping type. Port number is the difference between the software port number and the offset, and return. I think we can return not negative value. We can return 0 as the false, and here we return the true, and here return the false. So we need to write the description of the function. Convert the Focusrite control software port number to the pair of numbers. Hardware, port type, and hardware port number. Okay, and here I think we just need to add the additional description. Convert the hardware port number to the FC software port number. And since we know the port type and the port number, we can convert this port type and port number to the MUX port type and port number. So we can write additional function, static int Scarlett 2 get MUX port number. And here we have the port type. We have three values: direction, port type, port number, and the device info. This is the exact values. And we just write the function, and here we just need to convert the value. So we have MUX assignments, and we will work only with the MUX 1, and this will be true. So we will loop through the port type, and we will generate the actual values. So we have int MUX port number assigned to 0 at the start. Then we should loop through all port types. And so we have a loop variable int port type, I think current port type, and loop for current port type assigned to Scarlett port 2 type none. then current port type is less than Scarlett port type count, and we just increment the value current port type. Here we will write just the comment that we iterate over all port types and add the offset if the desired port type, if the provided port type doesn't match the current port type. So after that, we can do the following thing. We can compare the port type if, and here we should return the negative value. And here we can just compare the what should we compare the direction and port type if just port type if port type doesn't equal to info mux assignment. I think I can reduce the mux assignment table. Mux assignment, I think 0, then port type. I think I need to look how the mux assignment is defined. Mux entry, Scarlett 2 mux tables, Scarlett 2 max mux entries, Scarlett 2 mux entry, port type start count. Oh, port Scarlett 2 mux entry. Oh no, I don't need the port assignment, the mux assignment. I think I need to another data structure. I need just port count. Yes, I need just port count. Dot port count. Yes, I just need the port count, and here port count. If port type doesn't equal the current port type, so if we don't match the port type, first I need to write the match. If port type equals to the port count, then we do one thing, and else if we don't match, we need to increment the mux port number by the number of ports. Scarlett 2 port type. Info port count direction type port type and direction. Yes, that's right. It's an assignment. So we just add the value, and after that if we matched the port type, then we can just compute the difference, the offset. I think we'll just define one more variable, offset. We can compute offset as the difference between the between what Oh, we don't need the offset. We know the offset. We know the part number. Right, right. Mm. We just need to do. We just need to add port number to the current port number and just leave. And just leave. Yes. Just return. I think I can add some code for safety. Return port num is less than info port count port type direction. If this is true, then we return the correct value, the current port, the mix port number plus plus the port number. Otherwise, we just return the -1. So we have just simple check that we are in the range, in the correct range of the ports, and we return the invalid value if we are out of the range. So we have two functions, and now we can initialize these functions. I just need to write a comment. Convert the hardware port defined by these values, direction, port type, and port number, to the actual mux enum value of the driver. Of the driver. Right. And now we can just scroll the right panel to the our string, our line. This is 2015. Yes, that's right. And we will keep this on the right, and on the left we will go to the initialization of the mux. Add mux enums. And here we just need to define the additional two variables. I think this should be the int port, int software port type. I don't know the right, the better name. The one of the problems of the programming is the right naming of the variables. So the software port type and the we know about the direction. We just need to software port number. And here we have we have already the software port number. So we have the driver port type and driver port number. Okay. Okay, now let's see. We have the software port number, and now we can convert it to the driver port number. So if Scarlett to get software port mapping of no, not software, get hardware. I don't like the hardware. Get driver port mapping. Yes. To the pair of numbers, the driver port type and driver port number. Okay. And this is the mux. Yes. So we should store the port type and port number. So we pass the driver port type and driver port number. Driver port type and driver port number. Then we pass the info, and we pass the direction Scarlett to port in. This is input port, and the port number, the software port number. Oh, I think we can just return the none here. Yes, we can return the none here. So we can just do the void function. Oh, yes, we can do the void function and just store the none values here. So we write port type Scarlett 2 port type none. Port mapping type none. No, I don't like such mapping. Sorry. This is not good. I think I need to update the exit of the loop. Out of the loop, since we have the port type none mapping, we just don't. I think the port type count here. Yes, and after that, this is true. So I need to replace the port type count and update the functions that are looping until the Scarlett 2 port type count is set, and we need to update the the mute control assignments. So I need to go back to the add line out controls and change the count there, the value to count there. Yes. Count. I just need to check that port mapping type is not equal to something isn't different. This is normal. That's good. That's good. Yes, I've corrected the changes. Now it's good. So Scarlett 2 port type count, and now we're working properly. And here we don't need to check. We just call the conversion. We just do the conversion. And after we have the value read, we know the driver port number and driver port type. And after that, get the driver port mapping port type. And here we just need to write a port num to 0 to. I think we can just return to int that to check that this was properly converted or not, but this can be not touched at this moment. So we convert it to the value, and we need to convert the values about the driver port type and driver port number to the mux number. So we just define the variable. I think this definition can be moved outside the loop somewhere here and just used without type definition. And now we have the mux port number. Mux port number. And this mux port number we can get by just reading the proper value. And here the mux port number, I think also it can be returned as the 0. Since we have no right assignment, we can return the routing to the 0. This means that this is the port type none. So we can replace this with 0. Okay. And now we have mux port number, and we can convert the Scarlett to get mux port number. and pass the values the direction. Do we know the direction? Yes, we know the direction. Scarlett to port type in. Yes. We know the port type. This is the driver port type. And we know the port number. This is the driver port number. We also know the info. And we know, and we don't need to know anything more. So we can just rub the line, probably, or not. I will keep this. Okay. Don't like long function names, but I'm forced to do such call here. Okay, let's look then. We have the MUX port number, and now we can log this. So first of all, we will just log this. So log. I just need to call copy the log call from the code. I think USB audio info. Yes, and we will just output the routing. So we will just software routing, and we will write that we'll log all the values. We will log the driver port type, driver port number, and the software port number, and the MUX port number. So we will write the 02X is the software port number. Then we will write driver port number, write the driver port type, then write the MUX port number. MUX port number, this will be also decimal, and this will be routed to the port type plus channel, I believe. Sprint slice off enum Desker. That was Scarlett to ports. Oh, Scarlett to ports, port type, Desker. Oh, I think this can. I need to check. Oh, I think I can move this code from here to here. And this will help me to log the port name. So just string, and in braces I will write the coordinates and the overall index. So port type. Oh, just coordinates, nothing more. And just write the name of the port. This is S, and its coordinates. So the port type and the channel. And here I just need to pass the caster to int the software port number, the driver port type, driver port number, and the MUX port number. So we have 4 numbers here, and string, and 2 numbers here. So we will log this, ensure that we have right mux restoration. We have right mux state, and we need to watch which mux state we have at this moment. So we have monitor output 1 routed to NLEC 1, NLEC 2. I think we can set some specific settings to ensure that we have good routing. I think we can set here the NLEC 8, playback 8. Here we can set the SPDIF 1. Here we can set the ADIT 1. Here we can set the playback. What do you do? Playback 8. We can set the playback 1. Then we can set the SPDIF 2. Then we can set the NLEC 4, for example. Then we can set, for example, the ADIT 8. Then playback 3, for example. Then here the NLEC 5. Here the NLEC 6. Here then what can I do? ADIT 1 and 2. I think ADIT 4 and 5. We will assign the ADIT 4 and 5. ADIT 4 and ADIT 5. All right. This is the input settings. This is the output routing. Okay. Now what we have the routing set. We need to compile the kernel driver. So I think I need to go to the kernel directory, and I need to save the file. We will have many errors, I believe. I've saved the file, and we now just need to launch the make. The first make will be too long, I believe. Oh, I can just perform the make J8 right here. Yeah, we'll do in 8-thread compilation. This will speed up the make process a bit. Since linker is one-threaded, the linker will work long, but all previous work related to make files will do fast. So and now we will get many errors, I believe. Yes. So and we now we need to correct these errors. So the first line is 2025 or 1225. 1225. And what does it? Oh, I have an extra brace here. That's right. And I believe I need to relaunch the compilation, since this is a very critical problem and I need to relaunch. Okay, so there is port count. It does 20, 12, 1253. So 1253. There's nothing known about port count, port type. I am current port type, of course. If the port type matches the current port type, then also key. And then we just check that port number is less than and just return yes. So then 12.58 what's the wrong? Was wrong? 58 I've missed the brace or something else. I don't see the problem. Oh, I've missed the semicolon. Okay. Then 1260. What's the problem here? Mux port number is undeclared. Oh, yes, there's a typo. Okay. And then the 4011. So what's wrong here? The driver port type, driver port number, we're taking an address of these variables. And what's wrong? Get software port mapping. Oh, so get driver port mapping. Yes. Get driver port mapping. We've written this function. Okay. And what's next? The cast. Too many arguments into function get software port mapping. Oh, that's the same problem. So we need to relaunch the compilation and check for more errors. Okay, implicit declaration of function get driver port mapping. Probably. And what's the difference? Scarlett. Oh, Starlet. Oh, yes. That's the typo. That's the typo. Scarlett, of course. Scarlett to get driver port mapping. Okay. Just relaunching the compilation. We need to wait a bit. My tea already became cold. Almost done. Yes, good. Now we can just ls mode and grab the USB, and I believe there is, yes, there's a module, and we need to do RM mode, SND USB audio, and copy sound USB Scarlett or USB SND USB audio KO to leap 5 point leap modulus 5.15 RT25 custom RT, then kernel sound USB and the SND USB audio KO replace. And after that, we should just do the mod probe, the SND USB audio. Yes, now we are ready to check that our mapping was properly set. So I probably need to save the list of our connections. I'll just do short note. I'll do just short note. Where is it? Oh, one more file here. Okay, I'll just write them playback 8, then spdiff 1, then 8.1, then playback 1, then spdiff 2, then nlec 4, then 8.8, then playback 3. So this playback 3, then nlec 8, nlec 5, then nlec 6, then 8.4 and 8.5. This is our mapping. So this is the nlec 1.8. This is spdiff 1.8, and this is loopback 1.2. This is 1.2, spdiff 1.2, loopback 1.2, and this is nlec 1.8. So this will be so, and after this memo, we can just disconnect the device. Here we need to capture the output. Here it is. And now we can connect the device. All right. There's a lot of routing set. I don't know why. I think I need to reconnect the device. I think that some sound subsystem has did this. So I need to just reread this, reconnect the device. Yes. Okay. Okay. Here's our software routing. Uh, so, as we remember, we have analog output, then SPDIF, then PCM. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. This is the actual port index, right? Let's look into the code. This is the software port number. And this is the true assign. I just need to not to print this in hex. I need to print this in decimals. That's my failure. Anyway, we have the right port number. Then we have port type. Right? Do we have the port type? Driver port type and driver port number. The driver port type is 1, which means that this is I need to just to open the Scarlett again too. Port type analog. So we have analog ports connected. Is that right? I think something wrong. I think the routing has not changed. I need to check this in the upper configuration. So the analog routing was 0 to 7, and the actual port index is from 8 to 15. I need to check. I need to 18i8 device gen 3. Oh, I probably need to add the hardware of port offset. Yes, I need to add the hardware port offset. Even if it is 0, that's not right that I'm currently returning it without the port offset. So I need to add port mapping. Offset. Yes. Hardware offset. Yes. So that will be more correct conversion. Anyway, we're a bit wrong with the settings. And what's wrong? Mute switch capture mute, and after that the port type 201. Oh, I'm probably wrong. I did wrong conversion, I believe. I need to look again. There's something strange. I need to look at the F8 offset and what's stored there. Where's the F8? F8. 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. That's wrong values. As we remember, we have set another routing. So probably the driver didn't store the state of the device. I think I need to reboot the Focusrite control. Uh, it seems that in our case, the port connection is right. So we have if we look at the port mapping in our nodes, we'll have the map. Where is this? The analog inputs, then SPDIF, and then ADAT. So we need to see that first ports are first port is the analog of type analog, and I think that's right. Yes, port type analog, then SPDIF, and then ADAT. Yes, and the ADAT of index 0 and 1. So this is right decoding, but the routing is wrong. I think I need to reconnect the device and launch the Focusrite control again. So I need to disconnect the device from the Linux virtual machine. I've disconnected the device. I can recompile the kernel since I've made some small changes. I will just save the file and recompile the kernel. Recompile the kernel in the background. And while doing this, I will just connect to Windows machine connected to the Focusrite device. And it restored the state we've actually was seen. So I need to just route the analog 1 here, analog 2 here, and switch the ADAT 1 here, ADAT 2 here, and probably SPDIF 1 here and SPDIF 2 here. I think this is enough. Yes? Yes, and we just need to device. How can I just force to save? Edit device. I think the driver can be wrong. I just need to reconnect the device and check that nothing has changed. I've disconnected the device and I just connect the device and nothing should change. Yes, the routing is now correct and I just disconnect the device and connect to the Linux machine. Yes, I think the Focusrite control was wrong. It didn't send the changes to the device to store these changes. So I think it could work properly, and so I just need to do the. I recompile the kernel? I recompiled the kernel, and I just launched the module reload, and now I just. What do I know? Oh, now I will just so connect the device to the virtual machine and check for logs. So here we do dmisk-w and check for logs. First of all, what's wrong with the routing? I need to relaunch. I need to just disconnect and connect it again. Okay, let's look at the settings. So F8. So we see that our settings have been saved. There are not 1, 2, 3, 4, 5, and more. We have then 9 and A. And now we can look into the routing settings. And we see that 910 is mapped to port type 2. This is SPDIF, and 0 and 1. This is SPDIF 1 and SPDIF 2. And that's true. The SPDIF is the ADAT is routed, the ADAT 1 and 2 is routed to SPDIF, and the and analog input 1 and analog input 2 are routed to corresponding loopback 1 and 2 outputs. Good. So we have properly read the software routing of the device, and probably we can store these values in the MUX, and if the value have been changed, then we can launch the MUX update. So we need a flag that indicates that the MUX has been updated. We can do the change here if private, and now we need to look at the private device. Here the port type channel, MUX controls, add new control mixture, Scarlett I index. Oh, I is assigned here and incremented here. I don't like this about can be so. So I is the number of the MUX output of the MUX port. Oh, I need to ban the bot. So, all right. We have MUX controls. We have the private configuration. I need just to look at the Scarlett 2 data structure and look at the MUX settings. MUX updated. Mute switch, level switch, pad switch, demute, direct monitor, and there are MUX settings, I believe. MUX, yes. If private MUX and the index is I, doesn't equal to the MUX port number, I think this should be MUX input number. Or this should be renamed to MUX input number, yes. MUX input number. If it doesn't equal, then we change it. This should be assigned to this. And the flag MUX updated should be set to 1. Change the mux settings if they differ from the hardware ones. And here, if we have the mux updated, if we have the mux updated, then we need to call the set mux. Yes. If it is updated, then we will call the Scarlett to USB set mux of the mixture. Otherwise, we just call just return the error. So update the mux before exit if necessary. Okay. And now we have the mux settings restored from the device, and we also have the mux control put, mux CTL put function. Do we have this? We should have this. Mux enum CTL put, but I believe. No, mux. I need to check. I think I needed to go back to this function. I didn't leave the bookmark. Oh, and add mux enums. Here it is. So I need to add a bookmark. And we do have add mux enums, and we have the Scarlett mux src enum control info. Mux source selection control. I don't like this name. This is how the outputs are controlled, not inputs. Okay, and what's here? For port type this. Oh, this is info. Here we convert the port number to the port type and port name, and print this name to the enum. This is okay. And here we just get the value. So here we just form the info about the enum set. We form the list of enums, I believe, something this. Here we read the value. Yes. And here we set the value. Here we do the remapping. Yes. And after that, here we do the remapping. Okay, maybe this remapping. Okay, all right, nothing. So, then we have the value. If value changed, then we save the value to the mux and call the Scarlett to use bset mux. Yes, but except this, we need to check if the software config is present. and we need to modify this value. So if private software config, we need to translate the actual we probably need to we probably need additional function. We need to convert to the MUX port number to driver port number. Okay. This is the reverse function. So we need to write the reverse function to convert the MUX number to driver number. I think I need to rename to the driver port number to MUX. I will just replace all. Get MUX port number, Scarlett 2, and this is the Starlet 2. Starlet, again Starlet, yes. To Scarlett 2. Driver port number to MUX. Driver port number to MUX. ID. MUX enum. Okay, and now we have to convert it back from the MUX enum to driver port number. So Scarlett 2 driver MUX enum to driver port number. MUX enum to driver port number. And of course, we will have the same signature as here. So this will be port type, port number. There will be an info and direction and MUX port number. So this is very similar to the software port number conversion function. Okay. So in port type, port number, device info, direction, and driver port, and the MUX port number. And here we just iterate about the port around the all port types. So this loop is true. Current port type. Okay, we'll leave just current port type. If port type equals to current port type, then we do something. Otherwise, we do the MUX port number minus. We subtract the number of ports for this port type and direction. And after that, if the port type matches, we just check that MUX port number is less than port count and just return the if this is true, else we return false. Return 0. And here we will return 1. The conversion was successful. And we will write the port type to the value. We just need to check that MUX port number is less than. Else we just need to subtract this. So if MUX port number is less than number of ports stored in the info according to the current port type, I think I need to replace the port type with current port type here. This is more properly. And MUX port number less than number of ports to the corresponding direction. Then we just save the port type as current port type and the port num as the MUX port number, just this, and return successful result. And by default, we just set this to 0. And that's all what we need to do for conversion, and except write the comment. Convert the driver, the MUX enum value to the driver port defined by direction port type to the driver port number, driver port type and driver port number. Okay, that's good. And we just need to convert this value. We need to define two additional variables. This is int driver port type and driver port number. And if the conversion succeeded, if the conversion has succeeded, this is the driver port type, driver port number. Oh, we can just do the conversion here. So this and this. And pass additional arguments, the info. The direction is, of course, the Scarlett 2 port in. And the MUX port number is actually the val. And after that, we should have the additional the U8, the software input number. We need to convert the port type to the get software port mapping. I think also I need to rename the function, not get software port mapping. Their driver port number to software port number. Anyway, I will, and this is not get driver port mapping. This is not get driver port mapping. This is the software port mapping to driver port mapping. I think I also can refactor the name. I can shorten the name. The Scarlett 2 get driver port mapping get as software to driver port mapping. As software to driver port mapping. So this get software port mapping. This is get driver port mapping to software. Get driver to software port mapping. Now it's clear. And here, after that, we can rename the call the proper function to convert the driver to software port mapping. So get driver to software port mapping. There. Here also we can return non-negative value. I need to check. Oh, yes, it's better to have the negative value if we haven't converted the value. So here just we need to check that the value is non-negative. If software input number is assigned this and we pass the driver port, we pass the Scarlett port in, then driver port type, then driver port number, then we pass the info and do the assignment, and if the software port input number is greater or zero than 0, then we can do some stuff related to the MUX. We can update the private software config. Private software config MUX out MUX, I believe. I need to check the software config's data structure. This is software config and this is out MUX. Yes, this is out MUX, and write at the proper index. And what's the index? Oh, we have to write the software input number to the proper output number, and the output number we also need to get. So we get the input number here, obtain the input number, and here we obtain the output number. And here we have the software output number greater than 0 and software input number than 0. And if both are greater than 0, then we can store at the index of the software output number the value of the software input number. And here we just need to add the output number and do the conversion here. So we need to copy, obtain the output number, pass the index, probably index, yes, index here, port out, Scarlett port out, and here port out too. And here we need to pass not the value but the index. Okay. And we also need to check this. So we will do the exchange. So if error is greater than 0, and here we will, if error is greater than 0, then we do the exchange, and if okay, then we save that one into error. And here we need to update the software config. And here the commit software config, and we need to copy the call from somewhere. Here's the call, and we just copy the call. We pass the correct memory address to which has been changed here, and the size of the value stored at this index is just a U8, size of U8 or 1 byte. So, except I think we can set, we can comment this code at this moment and just print the log to ensure that we are doing the right things. So I will just write USB audio info and set the update software config. I think right in the C terms, that's all the outmux at the specified index should be set to the specified value in decimals. And here we will write the here is the output number, of course. Here is the output number, and here is the input number. So we just log the changes and how it will be reflected to the software area. I believe there can be errors converting this, and we need to check this first, and after we ensure that the values we set are correct, we can uncomment this code and look at the result. So I need to check again what's the index. So I need to check the function I've already looked. Add mux enums, and what's the index? The index is starting with 0, so it's pretty good. The index is starting with 0, and all should be okay. I just need to save the driver and perform the compilation of the kernel and check. I believe there will be errors. Yes, there are errors, and there is 1497 line. 1497, what's one? Is the Scarlett to USB setmux void? No, it's int. And what's the problem? Error. Oh, yes. I think this should be moved here and assigned to 0. That's key. And is that all? Yes, and it seems to be linking already. Current port type may not be initialized but still used. No. Okay. Okay, we have no problems with compilation. We can just... Oh, we need to disconnect the device. Yes. Yes, we have reloaded the driver, and now we can look at how the driver with the mixture driver will interact with our device. So we just connect the device. We see that the device has been initialized. The routing has been updated. Okay. All right. Let's launch the also mixer and look what happens. So we select the Scarlett device. And probably we need to check how the analog routing is set. At this moment, we see that it is set to off. I don't understand why it is set to off. Anyway, we need to check how it will change. Analog 1, MUX. MUX has been updated. Out MUX 0 is set to 1. And I need to check again how it is handled in our nodes. So the analog so the analog input 1 is located at the offset 0. As we remember, yes, I just need to copy this. Where's our nodes? I don't need this. Yes, I think this. So this is inputs, and this is inputs for 18i20. I need inputs for 18i8. So here they are, and here are outputs. Here are outputs, and outputs are the following. Here there are outputs. I think I need to move these values somewhere at the top to not to recall every time where that's located. So line output 1 or analog, or this is the same. Line output 1 is analog input 1 is assigned to line output 1. Okay. I think this can be the issue, since the somewhere is changed, something is changing the routing at the initialization stage, or maybe not, or not, or routing can be set by mutes. I think that's not. I think I need to look for the set mux call at this moment. Please wait. B set mux. USB set mux. Mute control. When mute controls are set, the USB set mux is called. So yes, something is triggering the mute of the device, and that's not good. Anyway, what do we have? We have the correct assignment. So if we check the log, we need to ensure that changing the analog from 1 to 2 will change the value from 1 to 2 in our log. Did it change? I don't see any changes. Here, the analog 3. So yes, 3 value 4, 5, 6, 7, 8. So I need to see that the last value was 8 assigned to the output. So where is it? Oh, updating mix 1, mix 0, and I don't see the result, whereas the value is computed. Oh, outmix is 8, yes. So I just need to make one more change. SPDIF will be 11. Oh, 9. SPDIF should be 9. I need to check. Yes. Then there will be A dots. SPDIF2 will be 10. Where is it? I'm a bit. Yes, 10. Then A det from 11. A det from 11. Yes, A det from 11 and 2, 3, 4, 5, 6, 7, 8 from 11 to 19, I believe. 18. Yes, from 11 to 18. And then we have mix A. Ooh, this value cannot be written here at this moment. And outmix -1. And I believe this won't change the driver. Yes, this won't change the state, and that's correct. This should not change the state. Okay, let's see next. There are mix, PCM1. PCM1 cannot be converted, I believe. So it's not pretty valid to use PCM. Oh, PCM is a playback. Playback starting with 19. Is that right? Yes. Playback from 1 to 8, 19 to 27. So PCM 1, 2, 3, 4, 5, 6, 7, 8. So the last should be 27. 26. What? 19. Oh, I probably run in computation. 9, 19, 20, 21, 22, 23, 24, 25, 26. Yes, that until the 26. And I need to correct this in my mapping. Yes. And after that, I think probably we have additional 2 PCMs. No, we don't have. No more PCMs. Okay. I see that the assignment of the ports is pretty correct. I just need to check another one port. For example, I need to check the SPDIF. SPDIF. Where's the SPDIF? Oh, here's the SPDIF output 1. And I need to check where the actual index is. What's the actual index is? The actual index is 8. I need to correct check. Yes, this is 8. Okay. And I need to check the loopback. This is PCM 10. PCM 10. I need to check the PCM 10. Where's the PCM 10? I believe it's somewhere at the beginning. Oh, PCM 11, 10, 11. 11. Okay, probably PCM 11. I need to check I need just to check to set analog 1 and check the index. Yes, it's the 10, and we need to check that this is 10. And all seems to work properly. And here the PCM index 11, index 11. Yes, now we are sure that our mix settings are properly set when we change the mixer driver. That's good. And now we can update the software config, uncomment this, set some routing, and check that Focusrite control will properly read this routing. So I need to disconnect the device. I need to recompile the driver. Oh, that's. I need to correct the code. Software output number. Software output number. That was mistyper. Software input number. Software input number seems to be correct. Make. Please make me happy. I think this challenge is already coming to the end and will continue at the next stream. So I will need to do some. Yes, there was a mistake. We need to check that the output and here output. We just need to ensure that our changes take effect in Focusrite control software center, and after that we can end this challenge. So we already are sitting around more than 3 hours, over the code, over the over the reverse engineering and writing driver. So especially for me, it's a bit hard to do such job indirectly more than 2 hours. So we will just make a check, ensure that the Focusrite control handles this well, and end up with this stream. Okay, so let's reload the driver. Now we can connect the device. So we see that the device has connected. We see some strange routing settings, updating MUX. There is software configuration modification. I don't understand what's working with the state of the driver at this moment. Maybe this is pulse audio. I don't like the pulse audio. Anyway, we need to check the state of the driver with also mixture. And what do we have in the routing? There are PCM 07, PCM 8, PCM 9, PCM 10 assigned to SPDIF. PCM 8. That's very strange routing. I don't understand how did we get this? And who has said this? Who's so dumb to set such settings? Anyway, oh, this is PCM. That's not interesting. We need to check how it's doing with analog outputs or line outputs. So we see that analog output is not set. So we'll set it to SPDIF1. The analog output we will set to SPDIF2. The analog output 3 we will set to analog 1. This will set to analog 2. This will set to analog 3. This will set to analog 4. This will set to analog 5 and analog 6. So we have set analog outputs with the SPDIF. We will route the ADAT to SPDIF, ADAT1 and ADAT2. And to loop back, we will send, what we will send to the loop back? I think analog 1 and analog 2 we will send to loop back. So this line 10, or PCM 10. Analog 1 and PCM 11. I think PCM 11 will set analog 1 and PCM 12 we will set analog 2. I also think that I have made some mistakes in reading software config, and the MUX is updated in some way wrong. I probably need to check the whole log tomorrow, and probably I will fix the problem related to the reset of the settings. Anyway, our device has updated the software config and then committed the config to the device, our driver, and we just can disconnect the device and connect it to the Windows machine and check how the Focusrite control will handle this. Yes, SPDIF1, SPDIF2, analog 3, 4, 5, 6, analog 1, analog 2, SPDIF to ADAT, and loop back to analogs. That's good. So we see that we have enhanced the driver, we have improved the code. The only thing left is to commit the code. So I will just copy the driver. I will leave. I think I will connect to the device. SH. And what's wrong? Yes, here it is. And I'll just copy the driver bin homework Linux Scarlett Gen 3 kernel, not kernel, sound USB git pull I need to wait a bit. Yes, that's not updated. And I just need to take another driver, sound USB, um, Scarlett, mixer Scarlett Gen 2. C, copy here, replace the original driver, git diff. Okay, we have added this. We have updated the port type count I did. So we have updated loop, we added additional comments, we added additional functions, and we added the handling of the what? Of the mux, the settings of the mux. And additionally, we have checked that software config is present and have updated the state of the driver in the software config. And here we just what do we do over here? We check that software config is present and update the routing. Update the routing. And that's all. I think this is pretty enough today. So we'll just git add dash git status. That's good. And git commit with message. Added support of routing persistence for mono channels. Please also recall that each channel in the device can be used in the stereo mode. Here, if we press the corresponding button. So I think we will discover the stereo mode in the next stream, and we will check what's happening with the routing why is it reset. I think that is interesting. I think I will check the routing reset issue not in the case of the stream. I will check it tomorrow or a day after this. That's an interesting issue, and I think this is probably what I've missed somewhere. Anyway, we have added, we have committed, and we push this to upstream Git. So that's all today. If you like the video, please subscribe. Also, click on the link to become new additional notifications. Support the project. I believe each donation from your side will help me to buy additional devices. And after that, we will get the driver done sometimes. Once we will get the driver done. So thanks for watching. Please share this video to your colleagues which like the programming and which like to look how there are people do their professional job. So thanks for watching. See you soon. I think the next week, the night from Friday to Sunday, we will do some coding again. Bye bye.